Bonjour, welcome to Wahsa Distance Education Center's radio Zoom classes. This is MBF3C, grade 11 college math, and I am Bronwyn Slate. If you'd like to participate live in today's lesson, you can call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM or on the television through Bell Express View channel 972. You are always welcome to join me live, even if class has already started, through the Zoom link. That is available through me, your teacher, and also your DEC. Our classes are scheduled on Monday through Thursday from 11 till 12 in the morning. And we are now currently in week 5 of our 9-week course. We are now officially halfway through all of our lessons, or all of our sessions. A reminder of what work to submit for marking. The support questions, the ones marked with the pencil icons, are not for marking, so you don't need to submit them. You decide which ones and how many of them to do. If you are understanding a concept, feel free to skip questions. Don't spend your valuable time on things that are not beneficial for you. However, if you're struggling with the concept and you need more practice, let me know and I can send you more practice. The answers are in the back of your booklet, so check your work to make sure you're on the right track. However, there have been mistakes found. So if something doesn't line up, doesn't make sense to you, let me know and we can check to see if that's an error. Key questions, the ones marked with the little key icon, are the marked questions, the ones to submit. So please do all of those questions, show all of your work, your steps, your thinking, so I can give you all the credit for your understanding. And then, yeah, those are the ones to submit. To submit your work for marking, there's 3 different methods. You can scan and send it in electronically. So you can actually scan with a smartphone if you have one. The iPhone has a Notes app that has a scanning capability, and the Android Google Drive app has a scanning capability. If you need help with that, I can help you. Also, you can just take a picture if that works better for you. Then you can send it to me through either email at studentwork@nnec.on.ca and then CC it to me, bronwyn.slate@nnec.on.ca, or you can send it through Facebook Messenger to bslateWahsa. The second method is to drop your work off into Lookout. We have an outdoor mailbox at our location, 74 Front Street, at our side entrance. We're the big red building next to the post office, and there's a small white mailbox next to our side door. We are currently working remotely, so it may take me a couple of days to get it if you drop it off there, but I'll get it and mark it and get it back to you as soon as I can. The third method is to hand your work into your DEC. Then your DEC can either send your work through the Express or fax it to 807-737-1732 or toll-free fax 1-800-463-7852. Always, if you have any questions or concerns, if you're struggling with anything, you're unsure, please contact me. My email address is bronwyn.slate, which is spelled BRONWYN.SLATE@nnec.on.ca. You can get me at Facebook. My name there is bslateWahsa. You can call the main office and leave a message for me there, and then I can return your call. The number is 807-737-1488, or you can call toll-free 1-800-667-3703. My current office hours are Monday through Friday, 8 a.m. to 2 p.m., and I'll get back to you as soon as I can. If you'd like to connect with me through social media, both my Facebook and my YouTube channel are under the name bslateWahsa. So you're welcome to friend me and subscribe to the YouTube channel. All of our radio Zoom classes are uploaded shortly after airing, and I share them on Facebook and they're on the YouTube channel. There's a playlist for our class. So there's also short videos explaining common errors or confusing concepts. So that's a great place to go. Something that's a building block for this concepts that we're doing. And also I'm putting some videos up that if there's specific parts of our course that are particularly hard, I'm doing a short video that's focusing just on that one topic that you can visit instead of going through the whole lesson or jumping to different parts in an actual lesson. Math is a super visual subject, so connecting with the visuals with the videos is going to set you up for the most success. So you can either join me live through the Zoom call or watching the replays on YouTube. That's going to really make the most sense in terms of how to attack these problems. If you don't have reliable internet access and you do have access to a computer, I can put all of our videos onto a USB key and send that to you. So just let me know and I can do that. Right, we are on day 18 of our course, and we are now diving into lesson 12, which is the law of sines. This is still trigonometry, but it's slightly different. So our learning goals are such that at the end of this lesson, you can say, I will be able to interpret information and then draw and label diagrams, specifically with the sine law. And I will understand how to use the sine law to find unknown sides and angles. Success criteria. I know I have met the learning goals because 1, I can label triangle angles and sides. 2, I can explain when to use the sine law. And 3, I can solve for unknown sides and angles using the sine law. All right, let's activate our brains and do a little bit of mental math. We know we are not big fans of the classic mental or mad minute often multiplication table tests. They did not help us learn our multiplication facts or any other arithmetic. They just stressed us out. So we do not focus on that, but we build strategies that are transferable and that get us comfortable using numbers. So today we're doing 54 times 36, and we're going to looking back again at partial products. We've done partial products a fair amount when we were doing factoring and expanding binomials, but we're just going to do a reminder of what that is. So how this works is that we are thinking about how the fact that 54 is really 50 plus 4, and how that is times 36, which is really 30 times 6. So then we can multiply the parts to make sure that that might be easier to do it in parts than to do it all together. If I'm writing this down, I like to use the box method to organize my information. I'm not super great at holding this information in my head. You might be able to do 50 times 30 and 50 times 6 and 4 times 30 and 4 times 6 all in your head and hold all that information in your head. You might not. So I like to write it down just to sort of track what I'm doing. So I have 50 plus 4 in my box times 30 plus 6. So 50 times 30 is going to be, well, I know that 3 times 5 is 15. And then so I know that if I'm doing 50 times 30, that's going to be increasing by 100 factor because I'm increasing it by 10 for the 30 and by 10 for the 50. So overall, it's going to be 1,500. Then 30 times 4. I know that 3 times 4 is 12. So 30 times 4 is going to be 120. 6 times 50. Well, I know that 6 times 5 is 30. And so 6 times 50 is going to be 300. And then 6 times 4 is 24. So now I can take all of those values and add them up. So I have 1,500 plus 120 plus 300 plus 24. So if I add them up, I have a total of 1,944. And that's one way that you can do double digit or triple digit or any number. You really can expand it to anything in terms of breaking it up into its parts and to do that multiplication. All right, let's move on. Our mind's on some engaging in some prior learning. It's how to label a triangle. So this is different than when we were labeling a triangle for primary trigonometry, but it's just generally the standard way that triangles in math, we label them. So first, this is for any kind of triangle. It doesn't have to be a right angle triangle. It can be an obtuse, a scaling, an acute, like can be any kind of triangle. So first, our vertices, which are corners of our triangle, we label with capital letters with our uppercase letters. So for example, I have capital D on one corner, on one vertice, capital E, capital F on my other vertices. And then our sides are our lowercase letters. Our small letters are what we label our sides with. So capital letters for vertices, lowercase letters for our sides. And the other thing to note is that the opposite vertices and sides match. So capital D is a corner, then the side across from that is small d. Capital E is a vertice, the side across from that is small e. Capital F is a vertice, the side across from that is small f. So that's really important for organizing your information as we move forward. All right. So we are now going to engage in our new concepts. So as always, when are we going to use this in real life? Well, today's lesson, I'm thinking building brain muscle, and really all of our course material, we're building brain muscle. So the same way that you do repeated action to build a skill or a physical muscle, a body muscle, we're getting comfortable with numbers and building our brains, making those new neuron pathways and expanding them and reinforcing them. So that's what we're doing in this course. Sine law is all around us, even if we don't recognize it as much. It's part of construction a lot. It's part of surveying, navigation. So it's something that is used in a variety of different industries, even if we don't really recognize it in the same way. It might not be something that we're all familiar with in our day-to-day, going to the grocery store, parenting, things like that, but it is something that's used in many industries. We're going to look at some conceptual understanding about what's going on. However, this is not in your IL booklet, and you do not have to know it. And we're not going to be testing on you. You don't have to prove the sine law, but I thought that it might help folks to understand where the formula comes from. Your IL booklet really just gives you the formula and then says, all right, go to it. Here are the questions, follow these examples. But we're going to go through the conceptual understanding. It might be confusing. If it's super confusing and not helpful, don't worry about it. It's okay if you can just use the formula and answer the questions, and that's all right. However, if understanding conceptually where the formula comes from helps you, this is the part that's going to explain that. So we're answering, why does the sine law make sense? In this moment, we don't even know what the sine law is, but we're going to figure out how the sine law is derived and why it makes sense. So we have a triangle. It could be any kind of triangle. I've just drawn this example, but it could be, doesn't have to be this type of triangle. We label our corners. So we have a labeled capital A, capital B, capital C, and then our corresponding sides. So small a across from capital A, small b across from capital B, small c across from capital C. Then what we're going to do is I'm going to cut my big triangle into two small right angle triangles. So I know that I can draw a line from one of my vertices. I chose vertex C and draw that line in such a way that I know that it's a right angle. So I'm defining that this line is a right angle. Is that a right angle from my side C, and it hits my triangle at my vertex C. So that's how I'm defining my two triangles. I have two right angle triangles, and they now have a side that is, we're going to call H for the height of those two triangles. So I have my triangle, one triangle, then now my sides are C, part of C, H, and B. And then my other triangle, I have A and H, and then part of C as my three sides. And you're going to see why we're doing this. So we're taking our one triangle, cutting into two right angle triangles to make it be able to manipulate them. So let's look at our first triangle. And so I'm calling it ACD. So it's just this one part of the bigger triangle. And our A is going to be our reference angle. So same as what we were doing in our last lessons, we're going to use the ratios that we do know. So we have our sine is our opposite over hypotenuse. So we're going to use that information. Then we're going to compare the opposite side to the hypotenuse side. And we know that that's sine A. So that still applies because I have a right angle triangle. I can do that. So here, sine A is equal to H over B, because our opposite over hypotenuse. Those are the corresponding names of those sides. So if we rearrange and solve for H, that is going to be B times sine A. That's just rearranging, just with variables instead of with numbers. All right, now let's look at our other other part of the triangle. So our other triangle, still a right angle triangle. And this time we're going to look at our reference angle B and say, okay, our opposite is our side H, our hypotenuse is our side A. And so sine B is equal to our opposite over hypotenuse, the same as before. And sine B is equal to H over A, because we filled in our values, which happen to be variables. So then isolating for H again, we have A times sine B is equal to H, just doing our algebra. And I'm just going to rewrite that as H equals A times sine B. So then looking back at our whole big triangle, and we figured out that H is equal to B sine A, and H is equal to A times sine B. That those both, in both those, when we looked at those two triangles, we figured out that those were two ways we could represent that value of H. So that means that B sine A equals A sine B, because they both equal that H value. So we can set those two things equal to each other. And then we can isolate, we can rearrange them a little bit. So I'm going to divide B sine A and A sine B by A, so that I cancel off A on the one side. And then I'm going to do, so now I have B sine A divided by A equals sine B. And then I'm going to divide that side by, I'm going to divide it by B. So I cancel the B off on one side. And that gives me sine A divided by A equals sine B divided by B. So what this is telling me is that in any triangle, the ratio of a side to, or the sine of an angle to the side is equal to the ratio of the sine of another angle to the corresponding side. So it's a side that's across from it, that's opposite of it. I'm going to say that again because it's confusing. So the sine of one angle, A, divided by the corresponding side that's across from it, so little a, is equal to the sine of another one of your angles, I'm going to say B, divided by the corresponding side, small b. Being able to see it is really going to help you. So this is just a relationship that we were able to prove because of using that primary trigonometry and figuring out that H was able to equal these two things. Okay, so then the other thing to note is that the same process is true if we were to make the height at any other vertex to cut the triangle. So if I were to cut the triangle from B, angle B to side B at a right angle, and compare the reference angle of A and the reference angle of C together, then that would still be true. So sine A divided by A, small a, is equal to sine capital C divided by small c. That's still true based on the exact same thing. I could just label my triangle differently or cut my triangle into two different triangles. And if I were to cut my triangle at A and have reference angle B and C, that means that the sine of C divided by the side of C is equal to the sine of B divided by the length of B. So that means in general, we have that sine A divided by A is equal to sine C divided by C is equal to sine B divided by B. They all are equal to each other. Those ratios are all the same. We can write them in any order. We just have to remember that it's the sine of the angle divided by the opposing side. So it's the sine of the A, capital A, divided by small a equals the sine of C, capital C, divided by small c equals the sine of B, capital B, divided by small b. This is why it's super important to label your triangles correctly. You generally write that in alphabetical order. So in your booklet, you'll see that it says sine A over A equals sine B divided by B equals sine C divided by C. It doesn't matter which order you write them in. We just write them in alphabetical order because we're creatures of habit. All right, so that's understanding where that law comes from. And now we're going to apply that law. If that's confusing and that did not help you, but you're comfortable just just trusting me that the law works and just using it to apply to the questions, that is fine. If you want to really understand where it comes from, spend some more time with that last little section. All right, so recognizing when to use the sine law. This is on page 21 of your IL book. So this is now in your IL book. So you need to either know 2 angle measures and 1 side measure. So your question has to either tell you two angles on one side. So I have example here of a triangle QRS, and I have two angles and one side, and then I'm looking for the other side. Or the other thing that was tricky with this is that if I have two angles and I have one side and I'm looking for another side, if the side that I have isn't across from one of the angles that I know, I can figure out that third angle, right? If I have a triangle and I have two of the angles, I can always figure out the third angle. Because remembering from last lesson is a reminder that angles of a triangle equal 180 degrees. So angle Q, which I don't know, but is across from my 7 meters, which is what my side length that I do know, is equal to 180, take away 110, my angle R, and 59, sorry, that's just a typo. So then that tells us that our angle is 11 degrees. Our angle Q is 11 degrees, which is across from our side length, that is 7M that we know, okay? Because we have to have, remember, they have to be like the pairs. There has to be angle Q and side Q, and angle R and side R, angle S and side S. We have to have them in those pairs. But if we know two of our angles and we don't have them in those pairs, we can always figure out our third angle. Okay, so the other thing that we could know is that if we have one angle measure, we know one of our angles and two of our sides, we can use it as long as one of the sides is opposite the given angle. So in this case, if we only know one of our angle, it has to be across from a side that we know, because we can't figure out our third side, and we can't figure out our third angle if we only know one of our angles. That's really, really important. It has to be, your angle has to be across from one of the sides that you know. So I have an example on the screen here where we have two sides and the angle is not across from the side that we know. We can't do that because we don't know. They have to be corresponding. So in order for those ratios to work, they have to be corresponding. It has to be the angle across from a side that we know. So it's really important that you don't use the sine law if that is not true. We will learn the cosine law will help us in that case, but at this point, we have to use the sine law, our angles and our sides have to be across from each other in order to figure this out. Okay, so let's look at an actual question, see what this all means in actual practice. So using the sine law to find an angle. So we look at our triangle is labeled ABC, and we see we have one angle, 72, which is angle A, and across from that, the side across from that is 18 centimeters. So we know a side, so we can figure out our ratio. Then we know that the angle that we're looking for, angle C, is across from our other side that we know, which is 15 centimeters. So because we have an angle that we know and two sides, with one of the sides being across from the angle that we know, we can use the sine law. So then we say, okay, our sine law we remember is sine A divided by A equals sine B divided by little b equals sine C divided by little c. Well, we don't need all three of those. We can pick the two that we need. So in this case, we have angle A and angle C. Those are our sides, and corresponding side. Little a is 18 and little c is 15. So that means that we're going to use sine A divided by little a is equal to sine C divided by little c. So then we input what we know. So sine A is sine 72, that's the angle. And that's over 18 because that is the A value. And then sine C, we don't know C, is divided by 15 because that C, our small c value, the side length of C, is 15. So we just substitute those values in. Then we're going to isolate for our sine C is what we're looking for. C is what we're looking for, so that's what we're going to isolate for, which means we're going to multiply both sides by 15 because we're just doing algebra, which hopefully you're very comfortable with right now. So that we divide, we're going to cancel off the 15 from the side with sine C. And so we end up with 15 times sine 72 over 18 equals sine C. So then we can calculate that, which is 0.792 5. Remember, we want to have at least 4 decimal places in order to solve for when we're doing have to do our inverse sine. So then we do inverse sine of 0.7925 equals sine inverse of sine C. And remember, this is what we did in our last lesson in the part 2 of lesson 11. So if you don't remember that, go back to that lesson. I'll link it in the show notes. So that means that sine C, sorry, this should be angle C. Typo. Angle C is equal to 52.4 degrees. This is why it's important to make sure that you make sure that your number makes sense of what makes sense. I'm talking about an angle in degrees, so that it should say angle C, not sine C. That's just an error on my part. And that's how we were able to figure out the angle. Oh, I think I forgot to tell you that this is why this is useful is that we don't have a right angle. If we had a right angle in our triangle, then we'd use the trigonometry ratios that we were using in the last lessons. But this is a triangle that doesn't have a right angle. So we need to figure out different ratios that are helping us. Sorry, I forgot to tell you that. All right, so using the sine law to find a side. So there's 2 different ways that we can do this. So the first method is very similar to what we just did. So we're gonna try that, and then we're gonna introduce a new method or similar method, but just a little bit of a tweak. So we have a triangle, ABC. We could name our sides something different, but or our vertices to something different. It doesn't really matter, the letters don't matter, but we have triangle ABC. And then we know 2 angles. We know our angle A is 65 degrees. Our angle B is 39 degrees. Our side little a is 30 meters. And our side B, little b, is across from our angle. That's what we're looking for this time. So because we have an angle across from the side that we're looking for, and another angle across from a side that we know, we can use the sine law. So we have sine A divided by little a equals sine B divided by little b equals sine C divided by little c. I encourage you to write it all out to help you remember it. Because we have a reference angle A and a reference angle B, we're going to use sine A divided by little a equals sine B divided by little b. We're going to substitute the values in that we know. So sine A is sine 65 divided by little a, which is 30, equals sine B, which is sine 39, divided by little b, which is what we're looking for. So now, when we have b in our denominator, when we're dividing something by b, it's really difficult. We can't just isolate. We can't move everything away from the side b. We need to make sure that our b is we're not dividing by b. So we're going to divide both sides by, we're going to multiply both sides by b in order to cancel the b off and make it so that we're not dividing by b, that b is on our top. You kind of think of it like that. So we end up with b times sine 65 divided by 30 equals sine 39. And then we're going to multiply both sides by 30 in order to isolate for b. So we end up with b sine 65 equals 30 times sine 69. And then we're going to divide by sine 65 again to isolate for b. So that cancels off. And we end up with b equals 30 times 0.6293, which is sine 39, divided by 0.9063. I just wrote it a little bit differently on my screen to fit. So that b equals 20.8 meters, which makes sense. It's a length. That's length makes sense. So we found a side. So that's basically the same steps. You find the information that you know, you substitute into the sine law, and then you're isolating for the unknown. This has a few extra steps in order to figure out how to isolate from the unknown, but it's the same things that we've been doing. All right, so then for the second method, which means that you have less algebra to do, we have to think about flipping our proportions. And what I mean by that, we're going to look at a not example related to sine, but just some numbers to understand why we can do what we do. So 1/2 is equal to 3/6, which is equal to 5/10, which is equal to 12/24, right? All of these fractions are equivalent fractions. They all are the same amount, just they look slightly different. So That's true. We know that that's true, that they are all the same. If we flip those proportions and we have 2 over 1 is equal to 6 over 3, which is equal to 10 over 5, which is equal to 24 over 12. Well, if we look at those are all equal to 2, the value of 2. That is still all true. So we can, the ratio is the same. The relationship is the same. The value is not the same. The first one, all of those fractions were equal to a half. They were this equivalent to a half. Whereas the second one, when we flip them, they're all equivalent to 2. So I'm not saying that when we flip them, they're the same number, but I'm saying that the ratio is the same. So in the second set of fractions, those ratios are still true to each other. They are all equal to each other. Hope that makes sense. If it doesn't, let me know and we can talk about it. So how this is useful for us is that sine A, capital A over little a, is equal to sine B over little b is equal to sine C over little c. So those are ratios, right? So that was, we're saying that those relationships are all equal. Well, what we can do is we can flip them so that we have little a over sine A is equal to little b over sine B is equal to little c over sine C. So those relationships, when we flip them, is also the same. I'm not saying that these two sets of sine law are equivalent. It's not that they're the same, but that the relationships are the same. If we flip them over, those ratios are still true, so we could use that, and that can be helpful. You see both of these examples of the sine law in your IL book, but it doesn't explain to you how they are connected or why they're both true. So this is my attempt at explaining why they're both true. If that doesn't help you, and again, you're just happy to use them and apply them, great. If you want to talk about it in terms of why that makes sense, let me know. All right, so we're going to use that. This is the second method to use a sine law to find an angle. So again, still we have the same question. So we have our angle B is 39 degrees, and we have side small b is what we're looking for. We have angle A is 65 degrees, and little side A is 30 meters. So this time we're going to use the one that we just discovered is still true. So we have little a divided by sine capital A equals little b divided by sine capital B is equal to little c divided by sine capital C. Still, which one? We have information about A and B. So we're going to use just small a divided by sine A equals small b divided by sine B. And so then we're going to substitute in our values. So now we have 30 is our small a, so we replace that, divided by sine 65 equals b divided by sine 69. So now we want to isolate for b. So this time, because we're isolating for b, we are going to cancel off, we're going to times both sides by sine 39 in order to cancel off the sine 39 to isolate for b. So we end up with b is equal to 30 times sine 69 divided by sine 65. Because I'm multiplying, I just rewrote it in a slightly different way because it was easier for me. So that equals b equals 20.8. So you can see we get the same answer as we did before, but it's just that we didn't have to do as much algebra because the algebra was already inherent in the formula that we picked at the beginning. So that's why finding a side length, it's easier to use this side. If you are finding a side length, it's easier to use with having your side lengths on top instead of having your side lengths on the bottom. But again, you can use either way. They're going to get the exact same answer. It's just whatever makes more sense for you. So knowing which formula to use, as I just said, you can use either formula anytime the sine law is required. Doesn't matter. They are exactly the same thing. You can use either one. But if you want to do less algebra, if that part screws you up, then when you're solving for angles, use sine A divided by little a equals sine B divided by little b equals sine C divided by little c. The angles, the part that has the sine has the angle is on the top, and that means it's going to be easier. You don't have to do as much algebra. If you're solving for sides, then use little a divided by sine A equals little b divided by sine b equals little c divided by sine c, because your side length is on the top. That's going to make it easier to solve for your side. And that's how you can figure out which one you want to use. Again, you can use either one in any situation. You just end up having to do more algebra if what you're solving for is not on the top. Okay, so if you want to pause the video and try some practice questions, this is a little bit of a confusing idea. It is something that is brand new, so it's understandable that it might take a little while for you to wrap your head around. But on page 24 of your IL booklet, questions 1 through 9 are all practice questions for this. We're gonna recap it and with consolidation, and then we're gonna do a bunch of practice just to be able to see what's going on. So a highlight of this lesson 12 for the sine law. So labeling your triangles is super important to keep your information organized. So vertices are equal to your capital letters or your big letters. Your sides are your lowercase letters or your small letters, and opposites, sides, and vertices have matching letters. So knowing when to use the sine law, so use it when you know you have two angles and a side, or you know two sides and an angle that is opposite one of the sides. That's how you can use the sine law. Which formula to use? So again, both versions work in all situations, but if you want to do less algebra to solve for angles, use sine capital A divided by little a equals sine capital B divided by little b equal to sine capital C divided by little c. If you're solving for sides, then if you're solving for sides, then you want to do little a divided by sine A equals little b divided by sine B equals little c divided by sine C. All right, so our success criteria 1 is that you can label triangle angles and sides with the correct letters. That's criteria 2 is you can explain when to use the sine law. So knowing that you know two angles and a side, or you know two sides and an angle that's opposite one of the sides. And 3, you can solve for unknown sides and angles using the sine law. So you can apply the formula and solve for unknowns. All right, so let's do some practice to continue working through this. So number 1, solve for the unknown. So we have a triangle, right angle triangle, right? That's the point, is that it's just a triangle, and it's labeled A, B, and C. C is our unknown angle. We don't have a number for that. Angle A is 47 degrees. Then side A, that is across from angle A, is 4, and side C, which is across from angle C, is 5. So I'm labeling my triangle A and C so that I keep them arranged properly. All right, I have an angle and two sides where one of my side is across from my angle, so I can use the sine law. I'm looking for an angle, so I'm going to use this form. I'm not going to write out the whole thing. I'm just going to write sine A over A is equal to sine C over C. I don't need to write down that sine B over B is equal to this as well, because that's not useful for me in this case. So I'm just writing it, the two parts that are equal, that are useful for me. So then I fill in what I know. So sine A is sine 47 degrees divided by side little a, which is 4, is equal to sine C divided by little c, which is 5. So then I want to isolate for sine C so I can solve for C. So I'm going to multiply both sides by 5 in order to cancel off the 5 on the side with the sine. So again, this is algebra. So those 5s cancel off, and I end up with 5 times sine 47 divided by 4 is equal to sine C. And so now we need to use our calculator. So I have our Desmos calculator here. We're going to do 5 times sine of 47, close a bracket, divided by 4. And that equals 0.914 This is the last decimal. 91419. So I'm going to say 9142 is equal to sine C. But I want to find angle C, so that means I need to do sine inverse of 0.9142 is equal to the sine inverse of sine C. So then I'm going to go back to my calculator and find my sine inverse. 0.4142, and that is equal to 66.1 degrees. So my angle C is equal to 66.1 degrees. There we go. We solved for one. Okay, let's keep going, see what else we can do. All right, question 2, solve for the unknown again. Then we have, so part A, in triangle, this little symbol, it's a little triangle, it means triangle. In triangle DEF, so that means that I have a triangle that is labeled DEF, solve for F. So I'm looking for side F, given that angle D equals 66 degrees, angle F equals 39 degrees, and side E equals 10 meters. Again, this is why it's really important that you know that how your triangle is going to line up based on the numbers that you're given. So we're going to draw your triangle. If you don't have a triangle, I strongly encourage you to draw it. It does not need to be perfect. It doesn't need to even remotely perfect. It's fine if your angles don't make any sense. Just label them properly and it's all good. So I have a triangle. Then I know that it's like labeled D, E, F. Again, you don't even have to label them in the same order that I do. As long as they're labeled correctly and matched correctly, it doesn't matter the orientation. So then I know, and then I'm going to label my sides. So I have little d across from big D, little e across from big E, and little f across from big F. So then angle D in my question, it tells me is 66 degrees. So I'm going to write that on my triangle, 66 degrees. Angle F is 39 degrees. Okay, so I'm writing that on my triangle. Angle F is 39 degrees. And side E is 10 meters. So E is 10 meters. And I'm looking for side F. So I'm going to erase, I'm going to erase my little d because I don't need it. So it's not helping me. So that I'm looking at my information and seeing if I can do it. Okay, so I want to solve for F. So I know that I'm going to have to use sine over little f, or in order to, we're solving for our side. So we're going to do f over sine f because we're solving for a side. So we're going to put the side on the top. And then I have to figure out, do I have a matching angle and a matching side? So here I know angle D and I know side E. Those are not matching. So I need to figure out something so that I have a matching pair. If I don't have a matching pair, I can't use the sine law. So I need to make sure, I need to see if I can figure out if I can get a matching pair. This is why it's incredibly important to know how to label your triangles properly. Okay, but I know two angles and I'm looking for, I don't know my third angle, but I can figure that out. So angle E, I can figure out because a triangle is equal to 180 degrees. So angle E is going to be 180 degrees, take away 66 degrees, take away 39 degrees. So I can do that quickly on my own calculator. 180, take away 66, take away 39 is equal to 75. So I now know that angle E, I figured out, is 75. So now I have, even though it wasn't given to me in the question, I now have side, little e, and an angle that match. So I can use that in my sine ratio. So I now can say, okay, so little e over sine big E is the pair that I'm going to use. And now I just fill in what I know and don't know. So little f, I'm solving for. So then I do sine of 39 is equal to little e, which is 10, divided by sine of big E, which we figured out is 75. So then to isolate for little f, I'm going to have sine of 39, and I'm going to multiply that by sine of 39 so that they cancel, is equal to 10 divided by sine of 75 times sine of 39. So that means that I can cancel off my sine of 39 and I just get f is equal to 10 divided by sine of 75 times sine of 39. And then we're going to go back to our calculator and we're going to do, okay, we're going to do 10 divided by sine of 75, and then all of that times sine of 39, and that equals 6.5 meters. So F is equal to 6.5 meters. And there we go. That's how we do that kind of question. All right, so part B, solve for an unknown again. So in triangle GHK, solve for angle H, given angle G is 72 degrees, that side G is 15 centimeters, and side H is 8 centimeters. Again, draw yourself a triangle. You can draw your triangle however you want. You don't just have to draw it oriented in one direction. Again, it really doesn't matter. I don't care if the angles are accurate or not. So I'm going to GHK. This is why we label things. So we're looking for angle H. We're given that angle G is 72. My drawing is epically awful, but that's okay because I'm labeling it and that's not what we're evaluating right now. This is just to visualize it. And I forgot to label my small sides or my sides. So my side across from angle G is little g. My side across from angle K is little k. And my side across from angle H is little h. Some of our letters look similar in terms of small and capitals. It's all good. Okay, so side G is equal to 15 and side H is equal to 8. So then we are looking for angle H. That is what we're finding. So let's see. Okay, we have H. We have the side across from H, so we have a pair there. G and is across from little g. We have that information. Our angle is across from a side that we know. So that's a pair. So we can use that information. We know what we need. We can use that information. So we say, okay, well, we're looking for an angle. So we're going to do sine of H divided by little h is equal to sine of G divided by little g. And now we're going to substitute in what we know. So sine of H, we don't know, but we can divide it by 8 because we do know that. And sine of G is sine of 72 divided by little g, which is 15. We're going to multiply both sides by 8 in order to isolate for sine H. Again, if you're super comfortable with this and you don't want to write it out the way that I'm writing it out and you want to do it a little bit shorter, that is fine. If you want to write out all the steps, that is okay too. So sine H is equal to sine 72 divided by 15 times 8. So we're going to use our Desmos calculator to do sine 72, close my bracket because I want that all divided by 15, and all of that times 8 is equal to 0.072. So sine H is equal to 0.7, I forget really easily, sorry, 0.5072. 0.5072. 0.5072, just reminding myself, 0.5072. Okay, so then to find the h, we need to do the sine inverse of both sides in order to cancel off sine so that we can isolate for just h. As you can see, it can get very repetitive, but it's important to not leave out any steps. So then angle h is equal to, go to our calculator, we're going to get our sine inverse, 0.5072 is equal to 30.47, so 30.5 degrees. And there we go. That's how you do those questions where it tells you what they are without any diagram. Draw yourself a diagram. All right, number 3, explain why the below triangle cannot be solved using the sine law. So we have a triangle, L and M, and we have 3 side lengths. We have side little m is equal to 51. We have little l is equal to 48, and we have little n is equal to 62. But we can't use the sine law because we don't have any angles. We don't know any angles. We have to know an angle in order to do the sine law. We could, if we just knew one angle, we could do this. We could know all 3 sides and know one angle, and we can use the sine law. But if we know all 3 sides and no angles, we cannot do the sine law. We don't have the ratios. We don't have enough information. All right, so let's do a word problem. Number 4, 2 guy wires, 27 meters and 15 meters in length, are to be fastened to the top of a TV tower from 2 points B and C as shown. So we have a diagram. How far are points B and C? So we have a diagram. We know that we have an angle from at angle B. We have an angle of 32 degrees. Side C is equal to 72. Side B is equal to 15. We see that we have a height. This is our tower, is our height. And we're trying to find the distance between B and C, which is side length A. We have a lot going on in here. We have to figure out what actually do we need to know. So if we're trying to find A, little a, which is the distance between B and C, we need sine of A in order to find little a, right? And if do we know 2 of our angles? We do not know 2 of our angles. So we can't find our angle A without knowing our 2 angles. That makes this tricky. So we need to find our side C, our angle C, so that we can then find our angle A in order to find our side A. So this is one that has steps. And that often happens with this type of questions, is that we need to do multiple parts. So we can't dive into what we need to do right away. We need to do a step first. So first we need to find angle C, so then we have 2 angles, and then we can find angle A. So in order to find angle C, we say, okay, well, sine C over little c is equal to sine B over little b. So then sine C is what we're solving for, divided by 27, which is little c, is equal to sine 32 divided by 15. I'm not going to write out all of the steps because we are running out of time. So we have sine C is equal to sine 32 divided by 15 times 27. So therefore, angle C, I really am skipping steps, but just for the sake of time, we're going to do, right, so we're going to do sine 32 divided by 15. I'm skipping writing down steps. I'm not actually skipping steps. We can't actually skip steps. So you may have noticed that I almost made a mistake on my calculation because I wasn't paying attention and Desmos caught it. So then I do sine inverse of what I just calculated, which is 0.9539 is equal to 74 3.5, so we're going to say 74 degrees. So angle C is 74 degrees. So now we can figure out what angle A is. Angle A is equal to 180 degrees, take away 32, take away 74. So that is equal to 74 degrees as well. That is just a fluke. It isn't always going to be the same thing. And now that we found angle A, we can then go through and figure out what side A is. Unfortunately, I've run out of time, so we don't have time to go through that. But as always, if you have any questions for me, if you want to work through that final problem with me, feel free. We can chat about doing that. Give me a call and leave a message and I'll call you back, or email me or Facebook me. This will be up on YouTube later today. I hope you have a lovely day. Miigwech.